Here we have a box of unknown mass and unknown tension, and let's see if we can find out the tension and the mass. So, draw a coordinate system in the following way: x and y. X is parallel to the ramp, y is perpendicular, and I could do sum of the forces in the y direction equals 0. It's a box at rest. So the tension, the up force, equals the down force, m times g. You multiply by little g, that's 10 meters per second squared. So you turn a mass into a force, a weight, by multiplying by g. Nothing I can do over there, but I can come over here, and then I can say the sum of the forces in the x direction equals 0. So since this is t, this is also t, because our pulleys right now have to be massless and they have to be frictionless. So that means both these tensions are equal. So the tension is the up the ramp force, and the mg sine theta, the parallel component of the 5 kilograms, is equal to the tension. That's why it's in equilibrium. So the tension, m times g, is 50 Newton. We'll make it 50 newtons with 2 significant digits times the sine of 36.87. Turns out the tension is 30 newtons. Now what's that mass? Well, now we'll come over here, and the tension is 30 newtons over here as well, equals m times 10 meters per second squared. So this is 3 kilograms, and this tension is 30 newtons. That's done. Now we have an unknown tension, and we do have, again, a massless pulley. So this tension is T, so we have a massless and frictionless pulley. That tension is T as well. Right away, I'm going to go over here and say that the sum of the forces in the hanging block equals, in the y direction, equals 0. So the tension equals 30 newtons, and I'll make that 2 significant digits. So this tension over here is 30 newtons. I'll put it right in the picture. And then once again, I do the sum of the forces. And oops. Let's make our x and y coordinates. The x is parallel to the component, the y is perpendicular. And so right away I see that if I work in the x direction, I can say that the sum of the forces in the x direction equals 0. So the up the ramp in the x direction is t, and the down the ramp is 6 times 10. This is 60 newtons. So it's 60. So the parallel, driving me nuts, this thing. 60 newtons sine of theta, that's the parallel component, equals the tension. And we already found the tension is 30 newtons. So 60 newtons times sine of theta has to equal 30. And when you do the math, you can see, let me erase this, you can see that the theta has got to be 30, because only 60 times a half gives you 30, and the sine of 30 is a half. Having a little trouble with my pen. Let me just get rid of it. See if I can fill these in here. So the tension we already found is 30. Yeah, my pen's not working. So we'll have 30 newtons, 2 significant digits, and 30 degrees, and that's it. Those are those 2 problems.